Let's see what quantum computers have for us today. It's a buzzword lately around the world along with AI. But first, why do we need quantum computers? The main reason can be said as to increase the ability to process large amounts of data. Computers today can process a really large amount of data and more calculations when compared with what we have in the early 2000s. It really got a long way till now, but with new challenges and ergonomic data around those challenges, we need much more efficient computers to process, represent, and use that data. Real world works on quantum principles as per the knowledge we have today. Representing the data in accordance with those principles naturally makes it easy to represent and study the natural or real aspects of life and its processes, says few experts. Now we got number of reasons on why. Let's look at how the quantum computer works. In classic computers, we store the data in bits, zeros, or ones. A quantum computer stores the data in qubits. A qubit can represent both 0 and 1 at the same time, which is called superposition. This means that 10 qubits can encode all 1024 numbers simultaneously. Qubits are represented by atoms, ions, photons, or electrons and their control devices in special junctions called Josephson junctions. These devices work together to act as computer memory and a processor. Superposition lets one qubit perform two calculations at once, and if two qubits are linked through a quantum effect known as entanglement, they can help perform four calculations simultaneously. 3 qubits, 8 calculations. A 30-qubit quantum computer would equal the processing power of a conventional computer that could run teraflops, means trillions of floating-point operations per second. So this is a brief overview of how they work and their efficiency, but there are few roadblocks in the way. Although quantum processor wafer is smaller in size, the system that is needed in order to work can take up the size of a car. Mostly consist of its cooling system that helps to preserve the quantum states and superconductivity of the materials used and reduce the decoherence. Indeed, the error margins also needed to be addressed before it's used for serious tasks. Other economic factors like power consumption, etc., are also needed to be optimized and stabilized. Now let's see what can they be used for in future. Our little speculations. They can be used to improve our AI models in facial recognition, large language models, and generative models improvement. We can also apply them in drug synthesis and research or combinational analysis. We can simulate the atoms with larger complexity and study in deeper levels. Optimization, cryptography, security and astronomical calculations and simulations, much more. Only time can reveal us. IBM is an active player in this field along with other players like Google, etc. If you want to experiment with them, you can use IBM Qiskit SDK to implement the quantum algorithms. This is so far a brief about quantum computing and their current state of developments. Technology can be a boon or curse depending on the discernment of the hands that they become tools for. Let's hope we use it wisely and advance as a civilization. Thank you. See you later.